Give me just a moment. How do I go back? This one? Okay, let's stop this. Just like this. Oh, my device is kind of throwing a tantrum. Okay, there was a question.
Yes, you told me this is Aaron Waldron. You told me text you. Whenever I get in class, that you know about remind you about our email.
I already marked you as excuse.
Okay.
Let me get these gentlemen. Yeah, Walton. I think I got Mr. Walton already. Edwards, Martinez, Aaron. We have a couple of those. Did it change? Okay. Oh, and there is a Martinez. In Maine. Okay. Okay, I let him in. Okay, so basically, I take attendance as I let you all in. Let me try to. I'm trying to make the change. Give me just a moment.
So I'm confused. Like, since I didn't take a screenshot, I only get like half of the attendance grade.
It's not that critical, really. Give me just a moment.
I just wanted to make sure I had. You know what I'm saying? I just wanted to make sure. That's why I asked.
Attendance. Give me just a moment, because again, my device is still like they kind of changed it, so it's like I'm trying to figure out. I haven't figured out the nuances of like their newer structure. Let's see, that's not right. Today, get back. Let's try this. Attendance.
But first, I got a question also.
Okay, hang tight. Just hang tight, gentlemen. See, that's screwing. That's not behaving properly. Okay, another thing that used to work is this. Okay, there it is, finally. Okay. So then, excuse. Yeah, so oh no. Generally speaking, I think it's probably a good idea that each of you just keep your own records, you know what I mean? Because one, I want you to be aware that these sessions I do live stream these, so I do have a recording. I have a couple of recordings. Mr. Walton, I know I saw his name. Is this for today? Yeah. Let me go ahead and mark him. And like they recently did an update across the campus. Let me get this student. So that's kind of like it's still throwing me off a little bit. I had to try to figure out how to get around it, but I think I got it. Okay, I'll let these gentlemen in. Let me share my screen. I know there were a couple of questions, so hopefully you guys wrote them down. Sorry for the late start. It's just me, just being human. Let me see. So the way I do attendance, right? Okay, so first with the attendance, you don't really have to, it's not that critical, right? It's not that critical. Really, attendance is just for record keeping. It only becomes an issue if we accumulate 3 or more unexcused absences, right? So, you definitely don't want unexcused absences there. So you definitely want to get those resolved. Usually I mark you as excused, it's really not that big a deal. It doesn't affect your grade at all. It really only comes into play in 2 instances. One, if a student has 4 or more unexcused absences, then you could be booted. It can mess with your money. Sometimes students aren't able to get back in, so you definitely don't want to be in that boat. You just want to make sure that you're not racking up a whole bunch of unexcused absences. But again, it doesn't affect your grade. And then the other thing where it becomes relevant is periodically administrators will ask me, hey, when was the last time you saw so-and-so? So then I check my records. Now, again, these sessions are live streamed to my YouTube. So there's at least one recording, right? And I usually do my attendance in 2 ways, right? When I first get here, like when the class starts, so I'm usually I'm waiting for 6 o'clock. Like today, I just wasn't, so we got a little bit of a late start, and then I usually check it again at the 15-minute mark. Now, Blackboard is good about attendance, like it has like an auto save, so when I let people in, you know, I let them in one by one. I take attendance, and then I go on about my way. But I do make mistakes, so you know. But again, just going forward, it's probably a good idea did you all like have some kind of record just in case you were here and you didn't get your credit, so then you can have something to prove it, right? Because then I don't, so that way it can minimize the clash, right? But for right now, it's really lax, and like I just mark people as excuse. I don't want, really, attendance is not really that big a deal. I don't want y'all stressing about that. I'd rather you just like focus on this content and get through the material, right? Now today is what, Wednesday. There was another question. I know there were. Let me kind of open the floor for questions real quick before I kind of go deeper. Going once, maybe it got answered. Going twice. Okay, I'm assuming that the question got answered. So I think the goal for this week is to get through section 1.4. So we really need to do 2 sections today. I'm not going to rush, right? I'm just going to go at my usual rhythm. But I'm saying that to say, whatever we don't do together, I do expect you to use my pre-recorded lectures and, take notes as if you're in class, and then write down your questions. And so again, our goal is to get through to the end of section 1.4 today. We're going to start at 1.3. Again, whatever we don't finish together, I do expect you to study it on your own, watch my recordings. Because again, the recordings are the same things that I would say live. It's just a recording, right? If something's not clear, you write down your question. You can email me. I provided an office cell phone number, so you can actually send screenshots and texts, and you can call that office cell phone number. Trying to think of what else. Okay, and so again, if you do have questions, feel free to unmute yourself. We can talk about it. Hopefully you all are gaining access to Pearson, My Lab, and Mastering. If you got like a Starfish report about attendance, just talk to me at the end of class. And again, right now, I've just been marking people as excused because I know we're all still kind of getting used to the rhythm and getting acclimated to everything. And again, I do 2 waves. So I'll look for the second wave of students in about 3 minutes. So with that, let's just kind of go ahead and start making our way through this next section. So we're continuing chapter 1 on differentiation. And so, we kind of introduced with limits. What did we talk about last time? I know we did limits, and then I think we talked about limits, a graphical approach, like, just a visual representation of what do we mean by a limit. So in this section, we're going to be looking at section 1.3, average rates of change, right? So the oversimplification of this is average rate of change is essentially just the slope between 2 points, right? That's all it is. Now, we might, kind of augment it a little bit or present it a little bit differently, but the main takeaway that I want you to get from average rate of change is it's essentially just the slope between 2 points. Now, we have several different ways of exploring this, so let's take a look at it. A few objectives here: compute an average rate of change and then find a simplified difference quotient. Okay, let's keep going. Okay, so definition 1, as x approaches a, the limit of f of x is L, written, this is pretty much what we've been talking about. And again, just kind of as a recap, limit is really just concerned with, it's generally concerned with, what happens when we're close to some x value, right? When we're slightly to the left of this x or slightly to the right, generally speaking. And then sometimes we're also concerned with, well, what happens to how does our function behave as x either runs to positive infinity or negative infinity, right? So either we're concerned with being close on either side of a number, or as x gets really big or really small. Okay, so this is red. The limit as x approaches a of f of x is L, right? If all values of f of x are close to L, for values of x that are sufficiently close but not equal to a, right? So, if we have our positive x here, positive y, say this is the a that we're considering, right? So then closer and closer to a from either side, we're concerned with what's happening to our function. Is it getting closer and closer to L? on both sides. All right. That's essentially what's going on. Okay, let's keep going. So the average rate of change of y with respect to x as x changes from x1 to x2 is going to be the ratio in the change in outputs to the change in inputs, right? So this is analogous to how you may have seen it in like college algebra 1 and 2. The average. Remember, I opened with saying that the average rate of change is just the slope between 2 points. So we're identifying our 2 points as x1, y1, and x2, y2. Right. So then now that we have our 2 points, that's pretty much straight from college algebra, right? So y2 minus y1 over x2 minus x1. Again, this is the rise over the run, which is the change in y over the change in x. Let me pause for the cause here and check my waiter room, or at least the second hand. Let me wait for 10 seconds so it can at least be 6:15 because that's my official time to check. I'm just stalling, trying to fill the air for like 2 seconds. Okay, we're good. Let's hop over to Zoom real quick. I just want to get anybody that's in the waiting room. Cool. Because I don't want people to miss this. The reason I do it this way is because I found that he keeps coming and going. This is like the third time I've seen his name, but it's okay. It's totally okay. I take my attendance this way because I found that like when I had an alert going, students like to trickle in, and so I was stopping like every 2 minutes to let somebody in to give their attendance and let them in. So to me, this is the best thing I can offer to not disrupt the rhythm and flow so much. Okay, this is a good question. How can I gain access to Pearson? Right. So to get basically here, let's hop over to, if I go to the portal, because this is pertinent, right? And I just need to make sure that as many of you all know how to do this as possible. So that's why I'm taking a moment for this. Just logging in. Come on, verify. Hope everyone's had a good day, right? We're here late. It just got dark. So if I go to Blackboard and I go to our course, and it's the weekend is here, right? I really think it is important to like, have some kind of recreation. It's a balance, and it's all about time management. Make sure to take some time to do what you need to do, but also enjoy yourself, like enjoy your college experience, because it's whatever you make it out to be, right? So, parties and traveling and just hanging out and just, having fun. But I cannot stress enough, please do what you need to do. Get your work finished, make sure everything is in order. It makes a big difference, like life-changing difference. So when you log into Blackboard, this is the landing page. If we click on this main folder, this is Calculus for Business Spring of 24. Here's our central hub. We got into the Zoom link. Anything that you see me writing, I load a PDF into that item number 2 that says Daily Lecture Notes box link. And then all of our assignments are right there in folder number 3 where it says all assignments. So if we click on that, you get these little icons that pop up, and basically you're just going to click on the first one. That says all assignments, right? My Math Lab, all assignments. So let me see. I think mine automatically bypassed the login screen, but basically just follow the prompts. So when you click on that first link, and it says all assignments, it's going to load you with a prompt for either log in or register as a student. If you've what is this? What book is this? I don't think this is the same book. Yeah, it's not. What book is this? Can I pull it up somewhere real quick? Let me see. Well, I will say that if you've used my Math Lab before with a professor that used this exact same book, as long as you log in with the same credentials, you don't have to purchase access again. But I'm just trying to see what book we're using real quick. Can I see the cover? I'm about to abandon this venture. It's taking way too long. Come on, let me see. Calculus and its applications. Yeah, okay, that's fine. Yeah, that's right. But again, if you did take a professor in the past that used My Math Lab and it's this exact same book, you shouldn't have to purchase access again. And if you do have to purchase access, I want to say it costs just shy of like $130. And then also on the page where you're prompted for payment, at the bottom, there should be a link that says get 14 days of temporary access. You want to use that when you know you're within 2 weeks of making full payment. Now, obviously, you don't want to stall too much because this work is stacking up. Now, I want to say I went on and assigned all assignments for the entire semester with the exception of the exams, right? I think there's 2 exams, one during week 6, yes, and one during week, I think like 14, right? And then the final. With the exception of those, everything else is available. It's just homework quiz, homework quiz. And so this week, again, we're trying to get through 1.4. So I think that was a good question. I'm glad we took some time to, recap that. Let me check on you guys' Zoom one more time, just for anybody coming late. Okay. I was getting into my rhythm and flow. Hey, yo, man, I don't even know. I don't even think I saw that movie, Hustle and Flow. I think I just watched a clip the other day. Somebody was making fun of it. He kept saying, hey, yo, man, or something like that. Let me check your chat one more time, but then we're going to get back on task. Let me see. Am I the only person? No. Yeah, okay. Yeah, so the Morehouse is like, the students, you guys let me know when we first got in. So, as long as you guys can connect with me, either like send me a text, call, email is fine too, because it's on record. And as long as you bring it to my attention for today, I probably mark people as excused. But you gotta like reach out, and connect. Okay, so when we left off, again, we were just kind of recapping. Average rate of change is just the slope between 2 points. So that's where we left off. Okay. So then now if we look at a graph of this function, right? Again, if we say y2 minus y1 over x2 minus x1, well, y2 is really just f of x2. y1 is just f of x1, right? So we can replace the y's with f, right? So if we have a curve, right, and we consider 2 points on the curve, a point P and a point Q, right? So then the slope between those 2 points we can find by, y2 minus y1 over x2 minus x1, right? Which is both the average rate of change and the slope of the line between P and Q, right? And so a line that crosses a curve at 2 points like this is called a secant line, right? So then basically what we want to consider, again, now I think when I first introduced chapter 1 with derivative, I think I said that the derivative is the slope of a tangent line at a point, right? But here we're looking at the slope of a secant line. Can anybody tell me what's the difference between a tangent line versus a secant line? Can anybody just explain that to me in their own words? What's the difference between a secant line versus a tangent line? Okay, that's okay. So a secant line is a line that crosses a curve in this fashion at more than 1 point, right? A tangent line is going to be a line that crosses a curve at 1 point. It's gonna like graze the curve kind of like this, or it's gonna graze the curve at 1 point like this, right? Versus this is not a tangent line, right? That crosses the curve, right? A tangent line grazes the curve at 1 point like this, right? So a secant line will cross the curve more than once. Tangent line is going to graze the curve at 1 point, right? So if we want to find the slope of the tangent line, right? Say we did it manually and we drew this as our tangent line. Is that the tangent line, or is this the tangent line? Or is this the tangent line? All right. You see how if we do it manually, you can get, some wiggle, and you can have like multiple lines kind of looking like they cross at 1 point. So how can we find like a unique exact representation or good approximation of the tangent line at a point, right? So what we're going to do, we're going to take the second point Q, and we're going to start to move it closer and closer and closer to P. So notice that the closer that Q gets to P, this line we get a better and better approximation of the tangent line at a point. So the secant line is becoming a tangent line, if that makes sense, right? So again, let me go like this, something like this, right? So we're interested in the tangent line at P. Oh, and then I can go, let's see if this works, okay? I'll do the best I can, right? You know, so if we consider this line, as Q gets closer, notice the line, we're going to get a better and better approximation of the tangent line at P, right? So, and so basically we're going to be taking the limit as x2 approaches x1, something along those lines. As that change between x2 and x1, as that distance tends to 0, then we get a better and better approximation for our tangent line at a point, right? Because manually we can't get it, so we have a way of approximating it, right? That's the takeaway, right? That's the main thing where we're doing this whole limit definition, right? Hopefully that makes sense. Right? That's the takeaway. So again, the idea is that that second point is moving closer and closer and closer to the first. And as it does, it's giving us a better and better and better approximation for our tangent line, right? Okay, so that's, I don't know how to say it any more clear than that, right? So, okay, so for example, given this f of x, we're asked to find the average rate of change as x changes from 1 to 3, 1 to 2, and 2 to 3. Okay, so these are basically just asking us to find the slope in these 3 different scenarios, right? So this was kind of okay. So for instance, for part A, so essentially, let me do like this. I have this urge to check. Now, no, okay, so what we're doing here, we're going to do, again, the slope between the 2 points. So we're saying f of x2 minus f of x1 over x2 minus x1. Okay, so then for part A, let me see. So that's going to be f of 3 minus f of 1 over 3 minus 1. So if we plug in 3, we get 9. If we plug in 1, we get 1 over 2. That's 4. So the average rate of change is x changes from 1 to 3. That's 4 for part A. For part B, we're going to be doing what? F of 2 minus f of 1 over 2 minus 1. So that's going to be 4 minus 1 over 1, which is what? 3. Okay. So then for C, we're doing what? F of 3 minus f of 2 over 3 minus 2. 9 minus what? 4 over 1. What is that? 5.
Excuse me, quick question.
Did I make a mistake somewhere?
I'm not sure. I wasn't trying to check for that, but more so about like, so in this specific example, y equals f of x equals x squared. Like for every time that we encounter this like scenario or like equation, we're always gonna try and are we all always gonna have to try and use that formula in blue on the right?
Oh, that's average rate of, that's just average rate of change, which is just
Okay.
slope,
Okay,
right?
cool.
So average rate, I can't write today. Average rate of change
That's
is synonymous with the slope between 2 points, right? We're just finding the slope. Yeah.
All right, thank you.
Right. So yeah, so we're just finding slope here. I feel like this is okay. 3 to 2, so that slope. So the slope is okay. So we're gonna kind of let that be, right? All right. So we got 4, 3, 5. For A, we got 4. For B, 3 and 5, right? Okay, so this is okay. Okay. So again, so far today, all we really have been doing is finding the slope between 2 points. And and I'm trying to connect it with this notion that, because really the derivative is just the slope of a line, but we need some way to find the specific tangent line that we're looking for, right? So again, secant line crosses the curve at more than 1 point. We're considering as that second point gets closer and closer and closer to the first, and as it does, we get a better and better approximation of our tangent line. And you'll see how we're going to do this, right? We still haven't really got to how to do it, but that's what I just described is the main concept or the main takeaway that we're trying to lead into. Okay. I usually leave the quick checks as exercises for you. All right, I think this goes deeper into like what I was talking about, right? So let's see. So the average rate of change of f with respect to x is also called the difference quotient, right? So difference quotient, again, is just the average rate of change, which is just the slope, right? So this is another way that we express the slope. It does take some like, algebra, right? So that's why college algebra is a prerequisite for this. And you'll see how it unfolds. At first glance, it seems a little bit intimidating, but then after a few iterations, like a little bit of exposure and practice, I think you guys can get it. Additionally, once we start getting into like the shortcuts for finding a derivative, you can just skip this. Like initially when we introduce the difference quotient, it's going to take up like the whole page, right? It's going to take up a good amount of space. But then we're going to start to explore like some different differentiation techniques, and that all the work that we did in the whole page, you can just look at it and just write the answer, right? So that comes after this, right? And to me, that's what I fell in love. I was like, oh, these are fun, these are easy, like these are smooth, right? That's what I like, the little properties, the differentiation techniques. But we're going to get into that in just a moment. Okay, so the difference quotient is given by this guy here, right? So in the previous slide, we were looking at x1 and x2, and then f of x1 and f of x2. Well, now instead of x1 and x2, we have an x right here. We just have x and then some change, right? So h is just some small change. So again, let me say that one more time. Instead of listing it as x1 and x2, now we're going to list it as x and some small change labeled as h, right? So h is just some x plus some small change, right? So, and let's leave it there for now, right? Again, h is just some small change, some positive small change, okay? So the difference quotient is equal to the slope of the secant line from x comma f of x to x plus h comma f of x plus h, right? And again, that's really just the first point and the second point, right? Okay. So the main takeaway is h is just some small change. And then, you can pretty much do what you did in the previous section and just replace x1 with x and x2, replace it with x plus h, right? Okay, so forget about that. So now let's see if we can see this in action. Okay, so for this function, we're asked to find the difference quotient when x is 5, h is 3, and x is 5 and h is 0.1. Okay, so the difference quotient, again, is f of x plus h minus f of x. This is like y2 minus y1 over, if we said x plus h minus x, this is the difference quotient. We're really just dividing by h. We're really doing x2 minus x1, okay? Okay, so, all right, let's plug all this stuff in. Let me think. So for part A, can we just do that? I don't see why not. So if our x is 5 and our h is 3 minus f of 5 over 3, right? So that's going to be f of 8. So that's going to be 64 minus 25 over 3. If that were 30, that's 34, so 39. So that looks like, is that 13? Right? We just plugged it in. Let's try B. This is still not there's a little bit more different quotient we need to get into, and we will. Okay, so here our x is 5 plus 0.1 minus f of 5 over 0.1. Okay, so f of 5.1. Siri, what's 5.1 squared?
5.1 squared is approximately 26.0099.
Siri, what's 5.1 times 5.1?
5.1 times 5 is 25.5.
Ah, she didn't get it. Hey, Google, what's 5.1 times 5.1?
5.1 times times 5.1 is 26.01.
Yeah, why did she say 0099? That was like throwing me off. Anyway, so when we say 5.1 squared, we get this result minus 25 over 0.1. What is that? 1.01? So 10.1? Okay. Looks like we get 13 and 10.1. Let me kind of clean this up just a little bit. Just a little bit. Okay. And then also one thing I want to mention about this course, like, I'm not trying to be super rigorous. I'm just trying to get you guys through chapter 4. Like, I would be doing you a disservice if I don't get as many people through chapter 4 as I can, because integration, you know, a calculus course is the only place you're going to get a chance to see integration. And if you leave a calculus course and you haven't at least been exposed to integration, that's a huge disservice, right? So I say that to say, you know, the rhythm might be a little bit quick, but again, I think with our pre-recorded lectures, you know, we can get through it with the minimum amount of anxiety. Also, to minimize your anxiety, things that you can do things early and try to get out ahead as best you can. Collaborate and definitely connect with the tutors early. Like, the more stuff you can do early, the better your experience will be. But when you start to procrastinate, you get pushed up against the wall. That's just not a fun place to be, right? If we can do anything about it. I think we got both of those results correct, okay? Hopefully we're all aboard, or we're not all aboard. Let me check on you guys in Zoom. The chat looks good. Okay, let me get this student. Let me update my attendance. Mike Jones. I know that's not his name. I did have a student named Mike Jones, and I don't think it was the rapper. I don't even know if y'all know who Mike Jones is, because I know that was a while ago. You know. Anywho, let's keep going. Let's go. Okay. So for this function, this one's kind of nasty. I kind of want to just leave it just for the sake of time. I'll go ahead and do it. All right. So for this function, find the simplified form of the difference quotient. Okay. So the difference quotient, let me think. Let's go here. So difference quotient is what? Here, let me write it. Let me write it here. So that's f of x plus h minus f of x all over h, right? So one way to simplify the difference quotient is just do each part separately, all right? So for instance, if we just, let's just focus on f of x plus h first. Let's just find that by itself. So that's going to be x plus h quantity squared, not squared, but cubed, right? So we know there's going to be an x plus h times x squared plus 2xh plus h squared. Then, let me see, x cubed, x squared h, 2x squared h, 2xh squared, xh squared plus h cubed, right? So one more. So then we have our x cubed. It should be 3x squared h, 3 h squared plus h cubed, okay? So when we cube the x plus h, you know, we get this, right? Being neat and organized, writing kind of big, these are things that you want to do, right? If you write too small, it's really easy to lose track of things. You know, if you're not neat and organized, it's really easy to lose track of things. Once you lose track of things, it starts to bore even more of a hole in your head, right? So a recommendation, give yourself plenty of space, write a decent size, take your time, you know, take a breath, you know, stuff like that. Okay. So when we cube it, we get this. Okay, so now we can go ahead and do the next part, which is f of x plus h minus f of x, all right? So we're just going to take our result, x cubed, 3x squared h, 3xh squared plus h cubed. Now we're going to say minus f of x, so this is going to be a minus x cubed. Since that's so simple, I'm just going to go ahead and tack on by the final part of dividing by h, right? Now, with with the difference quotient, when you're simplifying the difference quotient, you know you've done it correctly, generally speaking, when you're able to factor out your h's and get them to cancel, right? So for instance, this x cubed cancels this guy. And notice with the terms that are remaining, we can factor out at least one h. Okay, so if we factor out an h from the remaining terms, I think this might be enough space. We're going to have 3x squared plus 3xh plus h squared over h. And essentially, these guys cancel. This cancels this. All right? Okay, so being able to do that does take practice. And I know usually a lot of times like it intimidates students, but exposure, practice, collaborating, connecting with the tutors, asking questions, and having some grit and determination, it'll take you far. Like it will. But if you get intimidated, you get afraid, you procrastinate, that will take you far, but it might not take you where you want to go, right? If that makes sense. X squared plus 3xh plus h squared. I think that's the simplified difference quotient. That's the final result. Okay. So again, this is like an introduction, right? But again, in the next couple of topics, you like honestly, so the only thing that's really missing that we have to add on to this is, so again, remember h is like some small change, and we were considering the function as that second point got closer and closer and closer to the first. So then the way we kind of capture that second point getting closer to the first, we say take the limit as h tends to 0, right? So then here, if we took the limit as h tends to 0, this guy would go to 0, this guy would go to 0, and this would be our answer. So that would be the derivative of extends. We're going to be able to just start here and do the best you can with the difference quotient. But then once we really get into those shortcuts, really we use the shortcuts. Start here and finish here. We use those pretty much all the way into the end. Now we have some applications of them, but you're not going to be doing difference quotient like this all the way. This is like making a connection between college algebra and calculus, right? Okay. Okay. So let's keep going. And I think that what we have is good. Okay, we're gonna let that be. That's a quick check. Do I have the time? Let's do this. Let's do it. Okay, this was a little bit more challenging, but it's similar, right? So the difference quotient. So let's focus on here. Let me write the difference quotient up here. So that's f of x plus h minus f of x all over h. And then let's just do f of x plus h first. All right, let's just isolate that. F of x plus h. Okay. So we're going to replace each x with x plus h. So we're going to have an x plus h here. Okay. No simplifying going on there, so we leave it. So the next part, let's tack on the minus f of x. Okay. And so then that's going to give us this minus this. Okay. Let's go ahead and simplify this. Now, in order to add and subtract fractions, we need a common denominator, right? So I'm going to multiply by 1 in the form of, the common denominator in this case is x times x plus h. So I'm going to multiply this one by 1 in the form of x over x, and this one by 1 in the form of x plus h over x plus h, right? Just algebra, okay? So then that gives us, on top, we're going to have 3x. Now I'm distributing a negative 3, I'm distributing a negative 3 here. All right, I'm distributing a negative 3. So that's going to give us minus 3x minus 3h, okay, over x times x plus h. Okay. Notice that these guys cancel. Okay. And so then our simplified portion there looks like it's this x times x plus h under negative 3h. Okay. And then finally, the last part, we got to tack on that divided by h, right? So we have this f of x plus h minus f of x. So we got to say our answer divided by h, right? So I'll just write it here. So if we say this divided by h, right? When you say one fraction divided by another, we can do keep, change, flip, right? So we're going to keep the first one. If we do keep, change, flip, and then multiply, basically it's going to give us, I'll use some colors so we can kind of keep track of it. It's going to be h times x plus h under negative 3h, right? So again, when we're doing difference quotient, you know that you're kind of on track when you're able to cancel your h's. Now that we have all multiplication and division, we can cancel our h's, and the simplified difference quotient that we get this x times x plus h under a negative 3, kind of out of space. Okay. Bottom times 0 to the top minus the top times 0 to the bottom over the bottom square. Yeah, if you let h tend to 0, yeah, that looks okay. Minus 3 over x times x plus h. Let me see. Minus 3 over x times x plus h. Oh, ho ho. Okay, now we have a solid 30 minutes. I think I am gonna go into the next section with the remaining, and that's the section summary. So let me make a copy of this available for you all. I want to share, send it to Box. And this is the spring Morehouse traditional calculus notes updated daily. I think it's this one. All right, let's send that. And I'm going to go ahead and open up section 1.4. We'll do what we can with this 30 minutes. Whatever finish together, I do expect to use my recordings. Okay. So let's go here. Let me check on you guys in Zoom. So, hopefully that wasn't too intimidating. I was as clear as I could be with that, Let me get this student. So, So I'm glad. So hopefully you guys are seeing, if you're late, just wait, and it rhymes, so it got to be true. I'm marking these gentlemen as present, so it's okay. Again, attendance is really just for record keeping. It really only becomes an issue if we have 4 or more unexcused absences, or if an administrator is like, hey, when was the last time you saw so-and-so? So then I just check my records and I say, this was the last time I saw, and I keep it moving. Right? Honestly, on my end, I'm really like a coach or a guide. I just make the material or content available, and I'm just here rooting for you guys. I'm just here for support, just to answer questions, make myself available. But the learning most of it is really up to you, and you kind of being proactive and taking, getting the help, seeking the help and support that you need. Either if it's either me or a classmate or a tutor or the text or the book or a pre-recording or anywhere on the internet, you have to be proactive. Okay. So we have just about a minute per slide. Let's just kind of keep going. Okay. So hopefully we're all aboard and not all board. We only got a few minutes left. Here we have section 1.4, differentiation using limits of difference quotients. Okay. So we've actually talked about this, right? Again, the whole concept of derivative, we're talking about the slope of a tangent line at a point, right? But we saw it's kind of hard to get an exact tangent line at a point because you can wiggle it a little bit and it still grazes it seemingly grazes at the same point. So we needed a way to approximate that tangent line. And we do this, right, by, we start with the secant line. We have a curve that we consider the 2 points, and we consider the line that crosses at more than 1 point, essentially the secant line. And so you have your x and then some small change in x to produce that second point. So then again, the idea is we let that change tend to 0, which forces that second point to get closer and closer and closer to the first, which gives us a better and better approximation of the tangent line, and then, we can find the slope, right? It gives us a better and better approximation of the slope of the tangent line. Okay. Okay. Objectives here, find derivatives and values of derivatives and find equations of tangent lines. Okay. So the slope of a tangent line at a point is going to be given by here, right? So the slope, so this is like officially bringing together the narrative that we've been describing, right? So again, you got your first point P, you got your second point Q, and then as we let that change tend to 0, that second point gets closer and closer and closer to the first. So we get a better and better approximation of the slope of the tangent line, right? So this is official that the slope of our tangent line at a point is going to be the limit as h tends to 0 of the difference quotient, right? So in the previous section, we introduced the difference quotient. We worked a couple of examples there, right? And a lot of that is algebra. This is introducing the definition of derivative. Again, the derivative is just the slope of the tangent line at a point, but we use this limit definition to get the best approximation that we can. Now, after this, we have shortcuts where you don't have to do this difference quotient. So just do the best you can with the difference quotient. On the backside, I feel like the shortcuts are like exponentially times easier, all right? But a lot of this is just algebra. Okay. So let me say this one more time. So the slope of a tangent line at a point is going to be given by the limit as h tends to 0 of the difference quotient. Okay? The limit is also called the instantaneous rate of change of f of x at x. Okay. All right. Let's see if we can see this in action. So for a function y equals f of x, its derivative of x is the function f prime defined by, so f prime is going to be the limit as h tends to 0 of the difference quotient. F prime is the slope. It's the same thing as the previous slide. So f prime is the slope at that point, right? So the derivative is the slope at the point. Provided the limit exists, if f prime exists, then we say that f is differentiable at x. Okay. Let's see an example. So for this function, we're asked to find f prime and then find f prime of 3 and f prime of 4. Now again, when we start, because I'm looking at it, I already know the answer. All right. But for introduction purposes, we're going to start with the limit definition of derivative, and it's a little bit extra. But I want to say in the next section, you'll see we'll start to explore some of the shortcuts, some of the differentiation techniques. Okay. So we just said that the f prime is the limit as h tends to 0 of the difference quotient. So let's write that out. Okay. So in general, I'll write it here. F prime of x is going to be the limit as h tends to 0 of the difference quotient, which is f of x plus 8 all over h. All right. That's what the derivative is. Okay. So if we're going to do the limit definition of the derivative, again, and we're going to be using the difference quotient, let's just focus on f of x plus h first, right? So let's just find f of x plus h. And the difference quotient, to me, the simplest way is just do it part by part. F of x plus h, get your answer, and then subtract f of x, catch any changes there. Whatever answer you get there, then you divide by h, you simplify that. Then you take the limit as h tends to 0, and boom, you're done, right? All right, let's give it a go. So now if we're going to do f of x plus h, all right, that's going to be x plus h squared, which is x squared plus 2xh plus h squared, okay? So then next, let's subtract f of x, right? So now we're going to do f of x plus h minus f of x. So whatever answer we got, we're just subtracting f of x. 2x plus h. Okay. I feel like there should be questions. Hopefully I haven't lost you guys. Right. And that's fairly simple. We don't have a lot going on there. So I'm just going to go ahead and divide by h as well, because that's the final part. So then notice this x squared is canceled by this guy. And we can factor out an h from the remaining terms, right? Again, you know you're on the right track, generally speaking, when you can factor out an h from the remaining terms, right? So then we're going to have h times 2x plus h over h. This guy cancels this guy, okay? And so then one additional part now, so then our f prime of x is going to be the limit as h tends to 0 of this, what we have remaining is going to be this 2x plus h, right? And so notice here, only one term has h, right? So when we take the limit, basically this guy goes to 0, right? We just plug in, right? So then that's just going to leave us with 2x. Okay. All right. So that's f prime, right? So that's an equation of the slope of a tangent line at any given value of x, right? So then let's go ahead and find f prime of 3, okay? So that's going to be 2 times 3, which is 6. And let's highlight that so we can find it later. And let's go ahead and find f prime of 4. So that's a 2 times 4, which is 8. So if we were to look at the function y equals x squared, the slope of the tangent line when x is 3 is 6. The slope of the tangent line when x is 4 is 8, right? So if we just graph the lines with those slopes passing through that point, you can see it. I think these are good. These look decent. So 2x is good. -3? Oh, -3. Okay. So this should have been a -3, -3. That makes this a -6. Okay. All right, let me pause for the calls. I feel like there should be questions. We can hang out for like another 5 to 10 minutes. Let me see here. Now, if I notice that you guys start coming like the last few minutes of class, I might not let you in. Oh, I think is that for my next group? Are they in here for real? It might be my next. I think he's in my next class. I don't see him here. Yeah. Let me kind of take a few more minutes here. Okay. So for this function, find f prime. Now for this, I think it would be more simple. Well, I would rather just use my result that I had from last time instead of doing the whole difference quotient again. Here, I think we can do it rather quickly. So again, f prime of x is going to be the limit as h tends to 0 of f of x plus h minus f of x all over h. Now I think we can get this a little bit quick. So f of x plus h is going to be x plus h cubed. I think it was x cubed plus 3x squared h plus 3xh squared plus h cubed. Okay. And so that was the first part. And then f of x plus h minus f of x. So, essentially what we're doing is subtracting x cubed here. And these guys cancel each other. Okay. That gives us, so we're going to get 3x squared h plus 3xh squared plus h cubed. Then we got to say that result divided by h. So we can factor, so basically this h is going to cancel this one of those, and one of those. And then we're going to be left with 3x squared plus 3xh plus h squared, right? So then finally, to find f prime of x, we're going to take the limit as h tends to 0 of that. 3x squared plus 3xh plus h squared, right? So if we essentially we're just plugging in, this tends to 0, this tends to 0, and we're just left with the first expression. So that's f prime. So then once we have that, f prime of -1 is going to be 3 times -1 squared, which is just 3. And f prime of 1.5 is it 3/2? So 9/4, 27/4. 6, 24. So it's 27/4, right? Which is like 6 3/4.
Quick question. On the second line where we're crossing out like the H's and then also the like to the like the powers on that on 3x h squared, why do we cross out the squared?
Oh, okay. You talking about here in the part that I have circled in red?
Yeah, yeah.
You still there?
Yeah, I'm still here.
Ali Oxenfree? Can you
Yeah,
guys
can
hear
you
me?
hear me? Can you hear me?
You talking about here where I have circled in red?
Yeah, right there where you have it circled in red. Yeah.
I yeah, you were kind of fading. Is this
Oh,
what you're
sorry.
talking about?
Yeah, yeah.
Okay, so what I didn't write was factoring out the H's,
Mhm.
right? In the previous example, I was I factored out an H from each of those 3 before, right? I think in the previous parts or examples, like I'll do it here. I wrote it as like H times, if I factor out my H, it's going to be what? 3x squared plus 3xh plus h squared divided by h, right? This is what I didn't show. I just went straight to the answer.
Okay.
Yeah. So from there, let me hear.
All right, so then that's like the simplified version of it, and that's what you'd be your remainder would be that 3x squared plus that 3x plus the h squared.
Right. After you factor out your h's and cancel, that's what I had left.
I got you.
Yeah. Yeah. So again, I don't want you to be too intimidated. Just do the best you can with this difference quotient, right? Business. We made it almost halfway through this section, but we definitely are
I
out
got
of
a
time.
question.
Yes, go ahead.
So I'm a little bit confused where you got 3xh. I'm confused on that part.
3xh. 3xh. Where is it? Said it.
Like the first line?
So you mean like this part here in between the purple and orange?
Yes.
Is this it?
Yes.
So that came. I really pulled this because like we kind of did this a little bit earlier. This is just taking it a step further. Basically, from when I cube x plus h, right? If multiplying something by itself 3 times, this was the final result. Right. We kind of did it earlier. I just kind of jumped straight to the answer because we were kind of short on time.
Okay.
Like for instance, yeah, let me scroll back. Like if I go back to a previous example, I think it was in the previous section actually. It was one I kind of hesitated on. I was like, it's kind of long, but I ended up doing it anyway. It was in the previous section, right, where I wrote out these details, how I went from here to here. But you can like, this just means, let's do this color. This just means x plus h times x plus h times x plus h, right? So if you multiply 2 of them, you get an answer. Then you have to say the trinomial times the binomial, and you get this result. Okay. Let me just do a quick scan. So, we got our work cut out for us. You're definitely gonna have to take this and either watch the lecture again. Like some of the things that you guys are gonna have to do. Some of you guys can do this on your own, you'll be fine. So then my charge to you is if you can help as many of your classmates, that would be awesome. Some of you are like, you do what you can on your own, but then, obviously you team up with a classmate or connect with a tutor. Some students do use office hours, many do not. You just have your work cut out for you. It's going to take an effort. Like you gotta kind of gauge where you are, how you feel about it, make a plan of some kind of collaboration, and take some action. All right, just dust off the cobwebs. Do not be intimidated by this stuff. Like you wouldn't be here if you couldn't handle it. You can definitely handle this. You just got to know that you can, make a plan, and take some action. That's what you got to do. Okay, I think we got these results. Quick check is an exercise for you, F prime. We kind of did one similar to this. You just had to take the limit as h tends to 0. So I'm going to have to leave that. Quick check. Okay, where a function is not differentiable. Let me mention this real quick. So a function f of x is not differentiable at a point if there is a corner at a, right? So remember how when we were trying to draw a tangent line and, we can kind of wiggle it and be kind of close? Well, if we have a sharp corner, what's the tangent line? All of these are tangent lines, but it's not unique, right? So that's why we can't, that's why we say it's not differentiable at a point, right? At a sharp edge, right? If we have a sharp corner, then the function is not differentiable at that corner, right? We can't find the derivative. Also, it's not differentiable if there was a vertical tangent, right? So if it creates a vertical tangent, we say that the function is not differentiable at that point. Okay. Also, if there is a gap or a break, right? So notice here there's a gap, right? So when x is -2, it's not differentiable. Because like the slope of the tangent line coming from the left might be this, but it's not the same from the right. So the left-hand limit does not equal the right-hand limit, so it's not differentiable on this gap like this. Quick check is an exercise for you. And yeah, that pretty much got us there. We weren't too far off, right? We got through the meat and potatoes. Any other burning questions before we go our separate ways? Let me go ahead and make a copy of this available for you guys. The folder should be good, so I'm gonna just go ahead and send it. Yeah, use your resources, guys. I'm not being super strict. I'm not being super rigorous. My intent is really just to expose you to these concepts and encourage you to practice as much as you can, but I'm totally fine. Like if you took all of this material and sat down with the tutor and went line by line on your assignments, I'm fine with that. Right? I'm totally okay with that. I really just want you guys to be exposed to the material, do the best you can, but please be sure to submit your assignment so that, we can make sure that you get your credit. Any other questions, comments, or concerns before we go separate ways?
Yeah, quick question. Did you see my email?
What's your last name?
Martin Edwards.
Did you miss like class or something?
Yeah.
Let me see.
Tried to email and text you.
Hang tight. Edwards. Hang on. Martin Edwards. Okay, I'll mark it as an excuse for right now. Don't worry about it.
Okay, cool. But yeah, no, apologies for that yesterday. Or not yesterday, but last class.
Don't worry about it. Yeah. Others? Anybody else? On once? On twice? Hold your P's and rights. Okay. All right. So I'm available if you have questions about anything, and I believe in you guys. You guys can definitely do it. You wouldn't be here if you couldn't. God doesn't put more than you can bear, right? So you can definitely do it. You just got to believe in yourself. Again, make a plan and take some action. Learn as much as you can, but if you guys collaborate, just get this stuff submitted. All right. If there aren't any other burning questions, we're going to go ahead and end the session here. And from one beautiful mind to another, have a great weekend, guys. And I'll see you Monday, same time, same place. Take care. Peace. And I'm hopping right into the next.
See ya.
I have a question, sir. So regarding the Pearson signing in and creating your account with the textbook, is there an access code to join your class, or we have to purchase the
So
textbooks?
did you see the little walkthrough at the opening of class?
Unfortunately, I asked the question, but my Wi-Fi started tripping out, so I couldn't see the full walkthroughs. My apologies, sir.
You're good. So you access it through Blackboard. I would encourage you to just kind of pull up the recording of this from my YouTube channel, and I basically
I know how to I'm on Pearson. Like I know how to get on Pearson, but like the code, the actual code, do I have?
You got to follow the instructions because it's like you don't really go directly to Pearson. You go to Blackboard, and you have to access it through Blackboard because there's no course ID. It's like I linked it into Blackboard. So you go into Blackboard and follow the instructions, and then once you register, you're going to be prompted for payment. You do have to purchase an access code, but the course there's no course ID. You access through Blackboard. Yeah.
All right, man. Thank you.
Yeah. No worries. Any others before we go? Going once, going twice. All right, gentlemen. Have a good weekend. Let me see. There's one more.